For this example, we are asked to perform two tasks. The first task is to find the relative maximum or minimums. The second is to find the intervals on which the function is decreasing or increasing. For the first task, to find the relative maximum, then we need to find a point that is higher than any other point in its vicinity. In this example, we can see that it would be the ordered pair that's been given to us, -8, -1. Remember that a max or a min is a y value, and so for that particular ordered pair, we can see that the y value is -1. Because it's a relative max, we would want to say for this first part, relative max of -1 at x equals -8. For the second piece, to find the relative minimum, we want to find a point that's lower than any other point in its vicinity. So in this particular example, it would be the ordered pair -4, -9. Remember that a minimum is a y value, so you want to pick the y value off, which would be -9. So we would say there's a relative minimum of -9 at x equals -4. For max and mins, our answers are the y values. However, it's nice to have the x values that are associated with them, because the x values help us with the second part of this problem, which has to do with increasing-decreasing behavior. We know that for increasing-decreasing behavior, we are using open x intervals. So these are y values, and then these x's help us with our open x intervals for the second part. If you're ever asked to find increasing-decreasing behavior without identifying maxes and mins, you must first identify the max and mins so that you have these x values that you need. As far as increasing behavior, always start on the left-hand side of your graph and look to see what behavior is coming first. In this case, increasing behavior is coming first because we're going uphill. And so in this example, our graph goes forever to the left, so we would want to start with -infinity, and then it stops at the x value of -8. Always use parentheses around those values. Then our graph appears to be decreasing, so we're going downhill on the next part of it. So on there, we would want to use the x value of -8, and then it looks like it stops at the x value of -4. Then for the next piece of our graph, we appear to be going uphill. And so there we would want to add a piece to our increasing, so we would do union. The x value from that pair would be -4, and then because our graph goes forever to the right, we would say to +infinity.